Welcome to the deep dive. Today we're going to really get into Rift Valley fever, or Slenkdalkoors. Now this is a serious viral disease, mainly hitting hoofed animals, think cattle, sheep, goats. But here's where it gets really interesting and frankly concerning. It's a zoonosis. It's a significant health danger for people too.
Yes.
So our mission today is to unpack the sources you've given us, understand how best to control it, really focusing in on those immunization strategies.
Absolutely. And what's fascinating, or maybe critical is a better word, is that direct link, how managing animal health, directly impacts human well-being. This deep dive really highlights why understanding these zoonotic diseases and the specific challenges they throw up is just so important for public health.
Okay, let's start right there at the core. Rift Valley fever, a severe viral disease. What does it actually impact in animals? And can you expand on that human health link?
Well, in hoofed animals, RVF can be devastating.
Right.
High death rates, especially in young animals, lots of abortions. But as a zoonosis, it jumps to people, often through handling infected animal tissues, maybe blood, or even just mosquito bites during an outbreak. So controlling it in the animal population isn't just about livestock economics. It's fundamentally about protecting human health. It's paramount.
Right. So given how serious this is, what do the sources point to as the most effective way to manage this threat long term?
The evidence is really, really clear on this one. Sustainable immunization. That's it. It's the only truly effective control method identified. It's proactive, not reactive, builds up that herd immunity. And this is especially vital during wet periods because mosquitoes, they're the known vectors. They transmit the disease. More water, more mosquitoes, more risk.
Okay, immunization is the gold standard. But what about situations, farms maybe, where animals aren't vaccinated and suddenly there's an outbreak? Is there an emergency plan B?
Yeah, that's a really important practical question. In those outbreak scenarios on unvaccinated farms, you have to pivot. Mosquito control becomes the necessary emergency action. You need to break that transmission cycle fast. The best agents recommended are pyrethroids, specifically compounds containing deltamethrin. They're fast-acting insecticides. And that treatment, the mosquito control, it has to keep going until the animals have actually developed strong immunity after they've been vaccinated in response to the outbreak.
Got it. So mosquito control is a stopgap, really, until immunity kicks in.
Yeah.
Okay, let's unpack the vaccines themselves then. Sosa's mentioned two main types. Let's start with the live vaccine, the Smithburn vaccine. What's his story?
Right, the Smithburn. It's quite remarkable, actually. It was originally isolated from mosquitoes, believe it or not. Then it was attenuated, basically scientifically made docile or weakened by researchers at Onderstepoort Biological Products, OBP. So it triggers immunity without causing the full-blown disease.
And how has it performed? What's its track record like in terms of safety and effectiveness?
It's got a solid history, been used for nearly a decade, and crucially, there have been no observed cases of the virus reverting back to its dangerous form. That's a big plus. It's also relatively inexpensive, which is always a factor, and it generates good immunity, usually within about 3 to 4 weeks after vaccination.
And here's the bit that really stands out for me. Is it true that a single shot gives lifelong protection?
Precisely. That's the major selling point. One vaccination provides lifelong immunity. Think about what that means practically for farmers. Less handling, less cost over time, more sustainable protection. It's a huge advantage.
Okay, lifelong immunity, inexpensive, proven track record. Sounds almost too good to be true. Are there any, catches, any potential downsides or things to watch out for?
Well, yes, there is an important consideration. While it's highly effective, the live vaccine can cause a low percentage of abortions and fetal abnormalities. Specifically in pregnant ewes, sheep, if they're vaccinated during a very specific window between 30 and 60 days of pregnancy, that's a critical time for the development of the fetus's nervous system.
Okay, what kind of abnormalities are we talking about?
The sources mention things like hydrocephalus, that's water on the brain, malformed limbs, stillbirths, and of course abortions. So it's definitely something farmers need to be aware of with sheep.
That does sound like a serious issue for sheep farmers.
Yeah.
But is it the same across the board? What about cattle? You mentioned hoofed animals generally.
That's a key distinction. And interestingly, no. The sources state very clearly that none of these adverse signs have been seen when this same live vaccine was used on a large scale in pregnant cattle. So the risk seems very specific to use during that particular stage of gestation.
Right, that's an important context. So how does all this translate into practical advice for using the Smithburn vaccine? Who gets it when?
Okay, so animals of all ages can be vaccinated. But there's a caveat for the very young ones. Lambs, calves, goat kids if their mothers were already immune. Those young animals get antibodies through the first milk, the colostrum, and those maternal antibodies can actually interfere with the vaccine. So the recommendation is to wait until they're after 6 months old before vaccinating them. Also, ideally, vaccinate non-pregnant animals before the rainy season starts, before the mosquito risk really ramps up.
And what about safety during an outbreak itself? You mentioned using needles.
Yes, crucial point. During an active RVF outbreak, the very act of vaccinating, if you're not careful, can spread the disease. Contaminated needles are a real risk, so it's absolutely imperative use a fresh, sterilized needle for every single animal, no shortcuts. The dose itself is standardized. 1 milliliter given subcutaneously just under the skin for all species. Oh, and one last point. The sources make immunity can't be 100% guaranteed for every single animal vaccinated. There's always a little bit of biological variation.
Okay, that covers the live vaccine thoroughly. Now let's switch gears to the other option mentioned, the inactivated or killed vaccine. Why develop this one if the live one offers lifelong immunity?
Well, the primary reason was exactly the issue we just discussed with pregnant ewes. The inactivated vaccine was specifically developed for safe use in pregnant animals. It provides an option for protecting those vulnerable animals without the risk of causing abortions or abnormalities associated with the live vaccine in sheep.
Makes sense. But how does it stack up against the live vaccine? Is it as easy to produce or as powerful in terms of the immunity it creates?
No, it's generally more difficult and likely more expensive to manufacture. And critically, it just doesn't trigger as strong or as long-lasting an immune response compared to the live Smithburn vaccine. The immunity is, well, less robust.
And what does that weaker response mean for vaccination schedules?
It means repeat vaccinations are necessary. Unlike the single shot for lifelong immunity with the live vaccine, you need annual vaccinations with the inactivated one to maintain protection.
Okay, annual boosters. How quickly does the immunity develop after a shot? And, how long does that year of protection actually last?
Immunity starts developing about 2 weeks after the vaccination. It seems to reach its peak effectiveness around the 3-month mark, and then it generally remains effective for roughly 1 year, hence the need for those annual boosters.
Are there any other specific details on how to use the inactivated vaccine? Dosage, timing?
Much like the live vaccine, animals of all ages can technically receive it. And that same advice applies for young animals born to immune mothers. Wait until they're after 6 months old because of the colostrum antibodies. Again, vaccinating before the rainy season is the recommended strategy. Dosage differs slightly here, though. It's 2 milliliters subcutaneously for cattle, but only 1 milliliter subcutaneously for sheep and goats. And, just like the live vaccine, it's important to remember immunity can't be absolutely guaranteed for every single animal.
Right. So we have the two tools. The powerful lifelong live vaccine with a specific risk in pregnant sheep and the safer for pregnancy but less potent annually boosted inactivated vaccine. Bring it all together. What's the ultimate optimal long-term strategy the sources recommend for managing Rift Valley fever?
Looking at the big picture, the ideal approach, the best strategy laid out for the future is actually a combination used strategically. First, you vaccinate all animals initially with the live vaccine, just once. That establishes that strong, lifelong baseline immunity across the herd or flock.
Okay, establish the foundation with the powerful live vaccine. Then what? How do you maintain that protection over time, especially with new animals coming in?
Exactly. Once that foundation is set, the strategy is simple but effective. Annually, any new arrivals to the farm animals born there, animals purchased, they should also receive the live vaccine. This ensures that the overall herd immunity stays high, continuously reinforcing that protective barrier against RVF. It's about maintaining that robust protection population-wide.
That really paints a clear picture.
Yeah.
Wow, what a comprehensive deep dive into controlling Rift Valley fever. We've really unpacked how this one zoonotic disease needs these quite nuanced strategies, balancing, powerful long-term protection with very specific safety considerations for certain animals.
Indeed. It's the meticulous detail, isn't it? The specifics about the different vaccine types, the timing, the dosages, the different animal populations. It just underscores the level of scientific precision needed to manage these major zoonotic threats effectively, both for the animals and for us.
So what does this all mean for you listening in?
Well, I think it raises an interesting question. you look at these really tailored, quite intricate vaccination plans for livestock, and you wonder how might these kinds of detailed strategies inform or parallel how we manage other big diseases, whether that's in animals or even thinking about approaches to human health challenges. It's a really compelling example, I think, of how these targeted science-based solutions are just crucial for getting good public health outcomes.
Definitely food for thought, and a great reminder of how digging into the details, like we did today, can really help us understand the bigger picture, especially with something as complex as zoonotic disease control.